Welcome back to the channel. Today question is magic squares in grid. So a magic square is defined as a 3 by 3 grid filled with distinct number from 1 to 9 such that each row, columns and the diagonals have the same sum. So we want to find out how many 3 by 3 contiguous magic square subgrids are in the given grids, right? So given 438 for this thing, so we will have two 3 by 3 square, right? So starting from 438 all the way here, and the one starting at 384, right? So since the given example tell you that this is a magic square because it has distinct set from 1 to 9, and then the sum of each row, each columns, and the diagonals are all equal to 15. Well, this one's not. Clearly, you can see that 3 plus 1 plus 2 is 6, while 7 plus 6 plus 2 is 15, right? So from here, we know that that's only one magic square, so we want to return 1. So one way you can think about it as the way I would do it is the brute force way, where you just go through starting from 3, and then you go through like every element in this 3 by 3 square, and then see if that is a magic square, right? So we're going to start with the code straight away. So count equals to 0, and then we can say rows equals to the length of grid, and then columns equals to the length of the first element. So the row will be 3, the column will be 4 in this case. So now we can just go ahead and start writing out the for loop. So for R in range rows, and then for C, okay, I'll just increase this. For C in range columns. And then we notice that we not necessarily need to go through everything, right? When we hit 3, we know that, okay, this is the last 3 by 3 I can have. Because when we go on to 8, you cannot be forming a 3 by 3 anymore. So you can just do a -2 here. And then -2 here. Yep. And then, so now we're accessing this element right now, right? So for the first one, we'll point at 4. So we can set a distinct set for each of the 3 by 3 we'll go through. We set a distinct set, and then we set a valid equals to true. This is for later on if you find it's invalid, so you can break the for loop and then just getting out the for loop and go to the next one. So people get confused after they write this, and then they thought like, oh, okay, I can start doing it right without any other for loop. So the thing is, this nested for loop is just accessing the starting point. So once you get to the starting point, now you need another like nested for loop to go through every element for the 3 by 3. So I'll say for I, this is for the range, in range, for R, sorry, for the rows. R to R plus 3, because we're going to do it 3 times, and then this is not inclusive. And then we'll set a sum equals to 0. To keeping track the sum of the thing. So we'll do for this row, and then we go 4, 3, 8. So for the column, so for R in range C and C plus 3, and then we get to all the element right now. We're starting from 4, and then we go 3, and then we go 8. So we'll set if grid ij is less than 1, or you can just say equals 0 because of the constraint, or grid ij is greater than 9, or the thing already in the distinct set. This is why we need the distinct, because it maybe have 2 1s or 2 3 in the same column or row in the 3 by 3, sorry. So if this happens, we set valid equals to false, and then we break it. Why do we need this is because if we know this is false, right? So after processing one row, let's just break this inner for loop. So if we can have another thing like right here, we can also break this outer for loop, right? If we can say if valid equals go false, and then we can also break the outer one, right? I think in Python you can just say if not valid. I do it Java sometimes, so forgot about this thing. And then if it is valid, then we want to add the element into this thing. And then we want to sum the element. So after you sum all three on a row, like 4, 3, 8, we actually know a fact that when you have a 3 by 3 that field is 1 to 9, and then you want all the sum of the columns, rows, and diagonals to be the same, the sum will always be 15. So we can check that if sum is not equal to 15, and then we can also set valid equals to false. So in this nested for loop, we're done checking that each of the rows are sum up to be equal to 15. So 4, 3, 8, 15, 9, 5, 1 is 15, and 2, 7, 6 is 15. Now we need to do the column sum, right? Now we need to do, the next thing is the column sum. So we can say, we only do it if this is valid, right? If valid, and then we now need to check the column sum, right? So to check the column sum, we actually can copy paste whatever we have right here. Okay, the indentation is not good. All right, so for I in range R and R to R3, we change this to J. So now we're accessing the column first, and then we go to the rows. So in this case, you'd give you 492, 357, and 816, and then you can check it that way. So instead of saying sum, I call it column sum, and then I will say column sum plus equals greet, and then if column sum is not equals to 15, false. But notice that there's something I can check, right? Because we know it's already valid, right? So we don't need the distinct set anymore. We don't need to check this anymore. We can just set it to this, right? And then we said if column sum is not equal to 15, we can just set this to be false, and then we can just break it. All right, because there's only one way to make it to be false. All right, then we can check, sorry, then we check, so this is checking if valid, and then we check column sum, and then here we can say if valid, and then now we want to check the diagonal, right? Diagonal. I hope I spelled it right. Okay. So for this one, we just need to access the element for 4, 5, 6, 2, 5, 8, like that way. So I'll say first diagonal sum is equals to the grid RC plus grid R plus 1, C plus 1, plus grid R plus 2, C plus 2. So R plus 1 is increase one row, increase one column. So it goes this diagonal. And then D2 sum equals to grid R plus 2, C. So I'm doing this term first, and then going grid R plus 1, C plus 1, which is also the middle one, and then go, the last one should be R and C plus 2. So if D1 sum equals 15 and D2 sum equals 15, so we know everything is valid at this point, and then lastly we check the sum, and then the diagonal sum are valid. We can increase the count by 1. So first of all, we check each row, and then we check the column, and then we check the diagonal. So at the end, I need to make sure where I was. All right, so it's this line, this part. All right, so here, see, we're done with everything. Oh, so long. And then we can return the count. Let's try to run this and make sure it worked. Alright, for j, the local variable j is not associated with a value. Oh, I did not change this to j. Alright, so for j, yeah. Alright, it's accepted. And then we can go ahead and submit this. Alright, this is figure run time. So basically just brute force through it and then find, and then we have breakpoint, like the place to break, so we can like get out of the loop without wasting too much time, if that's like a case. And yeah, so this is the content for today, and happily coding.